Okay, see Lindelof videos, AP Calculus, second fundamental theorem of calculus. I just want to explain it a little bit. I'm a little bit shy about using this word proof, but I'm going to explain it and at least demonstrate why it's true. So what I'm going to do here is this. Just please be reminded that we're saying that it's possible that we have a function that is that's a definite integral, and this one that I want to do is 0 to x of t plus 2 dt. And we're asked to find f prime at x. And I'm trying to convince you that this is true, that f prime at x should be equal to x plus 2. What I'm going to do, instead of just doing this, which is what you should do on the exam, I'm going to actually prove this out a little bit. So what I'm going to do is I'm going to go ahead and integrate this a little bit. So I'm just going to rewrite this, and I'm going to go ahead and do my integration. So the integration of t is t squared over 2, isn't it? And the integral of 2 is 2t, isn't it? And we're going to evaluate that from 0 to x. So far, so good, I hope. As I integrate that, I'm going to use the fundamental theorem of calculus. So I'm going to take f of b minus f of a, and those are those values. So this is what I'm going to do here. So I'm going to say that f of x, in this case, is equal to x squared over 2 plus 2. Oh, sorry, plus 2x, right? Plus, oh, this should have been an x here. Sorry, 2x. Sorry, 2t. So I'm going to substitute in my x here, yeah? So that's this part, right? I just took the equation, I substituted in the first value. Now I'm going to do this. I'm going to take f of 0, which is 0 squared over 2 plus 2 times 0 in this particular case. And I'm going to say that my f of x function, f of x, is equal to x squared over 2 plus 2x minus 0. And I'm going to leave this 0 here because it's important. Because trying to prove to you that we are going to get that this is the answer, that we're going to get back to this answer right here, that f prime at x is going to equal to x plus 2. So remember that we're saying that f prime at x is going to equal x plus 2. So I can prove this through differentiation. So if I take f prime at x here, this goes to just x, doesn't it? And the first derivative of 2x is just 2, isn't it? And the first derivative of a constant is 0. So we did get back to there. So I really want you to take the shortcut. I truly do. But I want you to know that we're not faking anything. This is actually the truth. This actually does work this way. Let's do one more really quickly so you can see it, but I just want you to be assured. I think I'm going to try this one, I guess. That my function f of x, right? My function f of x is equal to the definite integral. I'll do 0 to x again. 0 to x again, and this time of t times t squared plus 1 dt. Right? So I need to prove to you that this is going to come back to be exactly what it was before. So let's see if we can't make that happen. So first thing I'm going to do is I'm going to simplify this. So I'm going to simplify this and say that my function f of x is equal to the definite integral from 0 to x of t cubed, right? Of t cubed plus t dt. That's just algebra, isn't it? I'm going to go ahead and integrate this now, and I'm going to get that my f of x is equal to t to the 4th over 4 plus t squared over 2, isn't it? As evaluated from 0 to x. So far, so good? So far, so good. Then I'm just going to take this through, and I'm going to take my f of x minus f of 0 thing. So f of x gives me x squared over 4 plus x 4th over 4 plus plus x squared over 2, right? And that's me just substituting in x here. Now I'm using fundamental theorem, so this negative sign is this one. and then 0. And this, I wish I hadn't used 0, but 0 is fine. I get 0 to the 4th over 4 plus 0 squared over 2. All equals, this all equals 0, doesn't it? So I can say, hey, my f of x in this case is equal to x to the 4th over 4 plus x squared over 2. Remember, we're asked to take f prime, so I'm going to go ahead and take my f prime. F prime at x is right, x to the, would be 4, so it would be 4 here, so it would be x cubed plus x, isn't it? X cubed plus x is my derivative here. And if you break that out just a little bit further to the way they started it, it is x times x squared plus 1. And isn't that where we started? Isn't that right here? Isn't all we did just replace those t values with x? T, like temporary. Because in this case, we're saying that this x is the upper limit. So I hope this is helpful. I hope this is a good demonstration of this. And I also hope that you don't do that demonstration, frankly, think your way through that demonstration too much when you're taking the multiple choice part. Just go through it. I do want you to really keep in mind that it would be different. We'd have to do something a little bit different if this, for example, was x squared, or this was 2x, etc. And I'm going to talk about that in the third video. So I hope this is really helpful. These are easy points to pick up on the exam, so I hope that you follow up with that. I wish you the best of luck, and if you haven't